students, this is Neeraj Bansal. Welcome back to my channel, Math Navigator. Today I am going to do one of the most important topics in physics, which is waves, right? So first of all, we need to understand what is a wave, right? So what do you think is a wave? Like you have gone through many waves, like the sound wave, it can be a sound wave. Then it can be a microwave. Light is also a wave, right? Then you have word of seismic waves, this, that, all this. So basically, we can categorize waves into two: mechanical waves and non-mechanical. What is the difference between mechanical waves and non-mechanical? Mechanical waves are those which can travel, which require medium for their propagation, right? Mechanical waves require medium for their propagation. Got it? I'll give you a very simple example. There is a very simple experiment when we talk about a mechanical wave, which is called a closed jar experiment, right? Let's say this is a jar, right? And here the wave is sent, the sound wave, by using tuning fork or anyhow. Then there is at the other end there is a person. Obviously, when the wave will enter through the jar, the person will be able to hear the noise, right? But what happens if we um, create vacuum, right? Then what happens? The sound is very less, or obviously there is no sound. Why I'm saying no sound? Because you cannot make 100% vacuum. So even if there is a little bit of air, then the sound will be moving. So from here we can say sound requires air for its propagation. Got it? Or sound requires medium for its propagation. Then there is another type of wave. I'll give you an example. What is a non-mechanical wave? Non-mechanical wave do not require medium for propagation. Basically, there are basically in mechanical waves, what comes in mechanical waves, you can say light. Why I can say light is a non-mechanical wave? So sorry, a mechanical wave. Why I can say the light is a mechanical wave, right? I can say it is a mechanical wave because it is a non-mechanical wave because it can travel through vacuum. So light is a non-mechanical wave because it can travel through vacuum. Perfect. Right. Then let's talk about uh, longitudinal waves and transverse waves. Before understanding, these, we need to understand how wave is created. So any wave, it can be any wave. Any wave is created by the oscillation of the particle. What do you mean when I'm saying any wave is created by the oscillation of the particles? In sound waves, the particles of the medium oscillates. That means the particles of the air oscillates about their mean position. Got it? So you might be thinking, when we require a particle to oscillate, then how the electromagnetic waves, or rather in easier language, the light wave propagates, right? Or light wave is created. It is created by the oscillating, or rather all electromagnetic waves are created by the oscillation of electric and magnetic fields, right? I'll explain what do you mean by the oscillating electric and magnetic fields. This you will study in higher classes, but I'll give you a little idea. Let's say these are three dimension. Let's call it, you can call it X, you can call it Y, you can call it Z. So in along with one of the axis there is electric field, along the one of the axis there is magnetic field, and along one of the axis there is a wave propagating. This can be the wave can propagate along x-axis, and electric and magnetic fields are along y and z-axis, and so on. It depends, right? But they will be mutually perpendicular to each. This, you again, as I've said, you will understand this in higher class. So now we have understood that any wave is created by the oscillation of the particle. But let's say if somebody, again in physics, it is very important to use technical terms. If somebody asks you, how do we define waves, right? So how do you define waves? In waves, wave is energy propagating from one point to another. No material is transferred. Clear? I hope this is very clear, right? So no material is transferred, only the wave is moving. So when we are saying that, like we have said three major things: no material is transferred, wave is energy, and it is produced by the oscillation. See, whatever you do in physics, that happens in daily life. Let's see, when we create a wave, whether these things follows or not. Let's say if I ask you to shout, for how long you can shout? Maximum 1 minute, right? Why? Because you will feel tired, right? Because when you are shouting, you are producing energy, and when you are producing energy, that means you are using some energy, because energy can neither be created nor destroyed, can only change from one form to another. So that means your muscular energy is getting converted into sound energy. Clear? So muscular energy is getting converting into sound energy. Then let's talk about um we have said that any wave is produced by the oscillation. So let's say if you are shouting more and you keep your hand on your throat, feel vibration. The faster you shout, the more vibration you can feel, right? So basically now we talk about the important parts of the wave. So when we are talking about the important parts of the wave, uh, so let's talk about. So first, we need to understand the important parts of the wave. Let's say this is my wave, right? The wave is moving. This whole thing is not a wave. Wave is only this much from here to here. This is one wave, right? This thing is called amplitude. And this is the time taken by the wave. Got it? This is also, if you plot x on the x-axis, you plot the distance. Then this is lambda. I'll explain you what all are these. First, we talk about amplitude. It is defined as the maximum distance traveled on either side of the mean position. Got it? Then t is equal to time period of a wave. See what happens. This is one wave. One oscillation produces one wave. As the second oscillation starts, this wave moves forward and another wave is created. So basically, it is like a wave train. So t is equal to time period of a wave. Now, when we are talking about time period of a wave, it is the time taken by the wave to complete one oscillation. Got it? Then we talk about frequency. It is defined as the number of waves in 1 second. Number of waves in 1 second. So amplitude is equal to, you can say amplitude can be the units of amplitude is equal to meter, right? The unit of time is seconds, and the frequency can be defined as 1 over t, 1 over time, which is 1 over second, which is second inverse, or it is normally called as hertz after the name of the scientist, right? So second, meter, and hertz. I hope this is clear, right? Then again, the very important term is energy. Energy is in case of sound is loudness. So basically, more is the amplitude, more is loudness or energy. So I can say intensity or energy is directly proportional to amplitude square. Intensity is energy per unit area. I is equal to, this again you will study in higher classes. Clear? So I can say intensity is equal to Ka squared. So wave, if wave has more amplitude, this means it has more energy. Now, another thing is pitch. Pitch refers to shrillness of sound. So pitch is directly proportional to frequency. That means frequency affects pitch. Clear? Then let's talk about the longitudinal wave. Longitudinal wave. In this kind, see, we have already discussed that the particles of the medium oscillates, or the particles oscillate and the wave is created. So in this case, in longitudinal wave, particles of the medium oscillates in the same direction as direction of propagation of wave. Right? This means if this is my particle, it is oscillating like this, and wave is also moving like this. So both the oscillations and the motion of the wave is in the same direction. When you will understand transverse wave, then it will become clear to you. So transverse waves. So what is a transverse wave? Transverse wave can be defined as transverse wave can, when the particle of the medium particle of the medium oscillates perpendicular to the direction of the wave. What does this mean? This means, let's say you are playing with your friend with the rope, right? You move your hand up and down and the rope moves like this. Got it? This means your hand is oscillating up, going like this, and then coming like this. With this oscillation, one wave is being created. One oscillation means one wave, like this. When you complete one oscillation and the second oscillation begins, this wave moves here with a certain speed, right? That speed depends on the nature of the medium. The denser it is, the higher is the speed, right? So this is how the wave moves, and this is the difference between the transverse and the longitudinal wave. Light is again a transverse wave, because as I've discussed, that electric and magnetic fields vibrate perpendicular to the direction of the propagation and perpendicular to each other. Got it? Then we talk about wave equation. Wave equation is nothing but relationship between the frequency, wavelength, and velocity. So V is equal to lambda f. Here v is equal to velocity of the wave. Lambda is equal to wavelength of the wave. And f is equal to frequency of the wave. Got it? So we'll do till here only, and in the next video we will move, like we'll continue with the wave. And this is the worksheet which I have made for the students, and I will discuss this worksheet once the topic gets completed, or I can discuss one or two questions with you so that you understand what kind of questions. Again, in physics it is very important to, what you'll say, it is very important to use the technical terms, like um like if you talk about question 1, define what is so I'll do this basic concept question. Define what is meant by the wave. Wave is an energy which moves from one point to another. No material is transferred, only energy is transferred, right? So question 1 is done. Question 2, state the difference between transverse and longitudinal waves. In transverse waves, the particles of the medium oscillates perpendicular to the direction of the propagation of the wave, and in longitudinal waves, the direction of propagation of the wave is same as the direction of the propagation of the particle, or direction of the oscillation of the particle. Give one example of a transverse wave and one example of a longitudinal wave. Transverse waves, there are many waves. You can give example. All electromagnetic waves are transverse in nature. And then you can say the wave on a string is a transverse wave. Water waves are transverse waves in nature. But in longitudinal wave, you have to give the example of a sound, right? Give an example of a transverse wave, and this we have done. In a transverse wave, what is meant by crest and what is meant by the trough? So positive amplitude is called crest and negative amplitude is called trough. In a longitudinal wave, what is meant by compression and rarefaction? Compression is where the particles of the medium, they come closer to each other, and in rarefaction they move apart from each other. You can represent compression and rarefaction in the form of crest and troughs. Define the following terms. Wavelength. Wavelength is the distance covered by the particle in one oscillation. Then frequency. Frequency is the number of waves produced in 1 second. Amplitude. Amplitude can be defined as the maximum displacement of the particle on either side of the mean position. And what is your wave speed? Speed of the wave, which depends on the nature of the medium, is called wave speed. State the unit of wavelength, frequency, and wave speed. Wavelength is lambda, which is in meters. Frequency is in hertz or second inverse, and wave speed is meters per second, which is the same as the speed, right? So I'll be attaching a link of this worksheet in the description box, and rest we will continue with this in the next video. In the meantime, please subscribe my channel.